The next refining process is electrolytic refining, which is based on electrolysis. Electrolysis is the procedure or a process of movement of ions towards their respective electrodes. Cations move towards cathode and anions move towards anode. These basic principle is taken for electrolytic refining, where we are going to take an electrolytic cell containing an aqueous solution of the salt of the metal of interest, and usually cathode will be the pure metal and anode will be the impure metal, and the common ion, having a common ion, will be taken as an electrolyte. For example, cathode, we are going to purify or refine silver. Here the cathode is pure silver, anode is impure silver. Electrolyte is the common ion having silver nitrate, an acidified aqueous solution of silver nitrate. When you pass current through this solution, the reaction that happens at the anode is silver solid will become silver ion with the release of one electron, and the silver ion will attract one electron and form silver solid. During electrolysis, what happens is that the anode silver atoms lose electrons and enter the solution. The positively charged silver cations migrate towards the cathode and get discharged by gaining electrons and deposited on the cathode. Other metals such as copper, zinc, etc. can also be refined by this process in a similar manner. Next one is zone refining. Zone refining is based on the principle of fractional crystallization. Fractional crystallization. When an impure metal is melted and allowed to solidify, the impurities will prefer to be in the molten state. That is, impurities are more soluble in the melt than in the solid state metal. அதாவது என்னென்னா மெட்டல்ஸ் வந்து பியூராக இருக்கிற மெட்டல் வந்து மெட்டலாகவே இருக்க சாலிடாகவே இருக்கணும்னு தோணும். இம்பியூரிட்டிஸ் வந்து மோல்டன் ஸ்டேட்க்கு ப்ரிஃபர் பண்ணும். ஹை பியூரிட்டி எலமெண்ட்ஸ் ரிக்வயர் பண்ணுற இல்லை சப்ஸ்டன்சஸ்க்கு இதை நம்ம யூஸ் பண்ணலாம். ஃபார் எக்ஸாம்பிள் செமிகண்டக்டிங் டிவைசஸில் யூஸ் பண்ணுற ஜெர்மானியம், சிலிக்கன் அண்ட் கேலியம் கேன் பி refined by this process. Here what happens is that one end of the rod, that is the metal, impure metal is taken in the form of a rod, and one end of the rod is heated using a mobile induction heater, which results in the melting of the metal on that portion of the rod. When the heater is slowly moved to the other end, the pure metal crystallizes while the impurities will move on to the adjacent molten zone formed due to the movement of the heater. As the heater moves further away, the molten zone containing impurities also moves along with it. They prefer to be in the molten state. The process is repeated several times by moving the heater in the same direction again and again to get the desired purity level. This process is carried out in an inert gas atmosphere to prevent the oxidation of metals. Elements such as germanium, silicon and gallium, which are used as semiconductors, are refined by this process. And the final method of refining is vapor phase method. There are two methods, which is Mond's process for refining and Van Arkel method for refining. Mond's process where nickel can be refined or purified by this process. The impure nickel is heated in a stream of carbon monoxide at around 350 Kelvin, and the nickel reacts with carbon monoxide and forms a highly volatile na easy evaporate agakuriya substance, highly volatile nickel tetracarbonyl, NiCO4 times, which is a gas. The impurities are left behind. Ni plus 4CO forms NiCO4 times. NiCO4 times. Again, on heating this nickel tetracarbonyl at 460 Kelvin, it forms the complex to give pure metal. Nickel tetracarbonyl, it forms nickel plus carbon monoxide. So, when you want to refine zirconium and titanium, the best method will be Van Arkel method. This method is based on the thermal decomposition of metal compounds, which lead to the formation of pure metals. Titanium and zirconium can be purified using this method. For example, impure titanium metal is heated in an evacuated vessel. What do you mean by the word evacuated? Vacuumized. உள்ள இருக்க ஏரை கூட சக் பண்ணி வெளியே எடுத்துரும். அதுதான் வந்து evacuated vessel. With iodine at a temperature of 550 Kelvin to form the volatile titanium tetraiodide. Again TiI4. அதான் வேப்பர் ஃபார்மில் இருக்க ஈஸிலி வாலடைல் இம்ப்யூரிட்டி. த இம்ப்யூரிட்டிஸ் ஆர் லெஃப்ட் பிஹைண்ட் அண்ட் தே டூ நாட் ரியாக்ட் வித் அயோடின். இப்போ வாலடைலாக இருக்க TiI4 இருக்கு இல்லையா, இதை வந்து அகெயின் டங்ஸ்டன் ஃபிலமெண்ட் வழியாக ஒரு பர்டிகுலர் 1800 கெல்வினில் ஹீட் பண்ணிங்கன்னா the titanium tetraiodide and pure is decomposed and pure titanium is deposited on the filament. The iodine is reused. I2 side byproduct கிடைக்குது, அது வந்து can be used. So here we stop with the extraction of metal. அண்ட் இதெல்லாம் நம்ம எதுக்காக பண்ணுறோம் அப்படின்னா, நிறைய யூஸ் இருக்குது மெட்டல்ஸ்க்கு. அந்த மெட்டல்ஸோட யூஸஸை தான் நம்ம அப்ளிகேஷன்ஸ் ஆஃப் மெட்டல்ஸை பார்க்க போகிறோம்.